We will discuss two-phase commit protocol now. So, two-phase commit protocol is a distributed algorithm which coordinates between all the distributed atomic transactions on deciding whether to commit or to roll back. So we have two parties, the coordinator and coroutes. Coroutes are the nodes which are performing the transactions. So this coordinator asks for whether to commit or not, like if the transaction is complete, then this coordinator asks for committing or rollbacking. So as per the status of this node, this court or node, that if it has completed its transaction like successfully without an error, then it gets prepared for the commitment, like commitment is yes or no. So in this prepare state, like prepare phase, this node it locks all the resources, save its state, the transaction state, and then it gets prepared. And after it gets prepared, it just votes yes or no. After all those nodes have like voted for yes or no, then this coordinator again decides whether to commit or roll back. So the decision of committing and rollbacking is on the coordinator, and the basis on which it decides is either all commit or all rollback. That means all those nodes, they have to say yes. If all those nodes, like we have n number of nodes like 10, 12, and if all those 10, 12 nodes vote for yes, then and then this coordinator will commit the transaction. Otherwise, even if a single node vote for no, then the transaction will be rollback. So this is the main concept of two-phase commit protocol, which is either all commit or all rollback. So these are the two phases: prepare and vote, and then commit or abort. So now let's quickly see the program. So we'll be using a client server type of environment for this program. So let's begin with the server. So we'll use like as we'll be having more than one client. So we'll be using list. Thread is the name. So thread is of list type, which will contain the list of all the connected clients, and this data, it's also of the collection type list. It will contain the messages or the data sent by the client. Now we will initialize these lists. So array list is quite similar to linked list in C++. Now socket, for client socket, we will get this socket here, then server socket for connecting to this socket, then port number. This is the object creation of the own class, server class. Now to this server socket we will map this port number. The server socket will assign this port number to this server socket. Now this is just for until the server is on. So the client socket will accept the clients on this server socket, and then then a new client thread will be created for the upcoming client. Like we will pass the server and the client socket for creation of the new client. Okay, so this client is a multi-threaded client. Like this server can entertain more than one client. So we will be using a multi-threaded environment here. Yeah. So as we are using a list here, so we have to add every new client coming. Like this is the server thread, and on which we will be adding new client every time whenever a new client joins. Just to show the total number of clients and data, yeah. And here we'll be adding the data or the message that the client will be passing. We will see what message the client is passing to the server, and then we will start the thread for the client. That means the client is now instantiated. Fine. Now let's come to the client thread class. This class extends thread. That means this class will definitely be having a run method which will be run when we will start this thread. So these are few fields which we'll be using. The line for getting the line, like whatever the client is sending. Then name, print stream, reference OS. Print stream will be using to print the data, to transfer it, not to print, to send that message or data to client, and data input stream will be using to get data from client. So like this input stream and print stream will be like a pipe to client. Most of you are familiar with these things. We have already done the client server program. It's quite same as the client server program, but the only difference is here. So this is just object creation and referencing for input stream and output stream. Now here the server asks client to enter his name, her name, his name, like its name, and it gets the name. The name will be the client's identity, and it just print a message to client, welcome to this two-phase commit protocol and this thing. Then the server prompt to the client that please enter commit or abort. Like this is the phase. This is the phase after. Just a minute. Yeah, this is the same phase, like when the server will ask client whether he wants to commit or not. Yeah. So this logic, yeah. So this logic, it actually prints this message that and every time a new client is entering or new client is connecting, so it just displays to other clients that a new client has entered. So this is again the list of the clients which are connected, and get I will give that, like on this index, on the ith index, which client is connected. If it's not the same, then it will show this. So now this is the code logic of committing or aborting, starting from this while. So now this line is dot read line. It's just a method of input stream to read the line. So if this line equals abort, like if in case the client has voted for abort, so this thing will happen. Okay. So it will print that from this object, from this client, the abort is done. Yeah, since abort, yeah. So here it will display that this client has aborted and we are all now aborting. And to other, like for instance, the client 2 or client 3, client 3 has aborted, so to rest of the clients it will show this global abort message. It will close the input and output streams, and we are done here. But in other case, if the client, like if client vote for commit line dot equal, ignore cases for just like it can be small or capital commit, no issue. So in that case it will print that this client has committed, and so data index, and yeah, it will. So now here the data which the server, the client was sending, so yeah, this the list which contains the data sent by the client. So we will update this list with commit. So server, to the list of server dot list we are writing here because the server is having the list of all the clients, and the list name is data. We will set server thread, like on which thread index of this, like the current thread. The current thread means that this is the current reference. So on the current thread, the current client which is connected to this thread in the server, in the client list on the server side, we will set commit. Okay, I will explain this thing once again. Server.data is the list in which server is keeping the data which is sent by the client. Fine. Now server.thread is the list which contains all the connected clients, and index of this means the current client which is connected to the server. So the data, so now this, if like the current client which is connected will send commit. If it sends commit, then the data part corresponding to this thread, like this client, will be set as commit. Fine. And if not, equals not sent. And if in case the server is waiting, so this logic is for waiting. So if it's waiting for like after, like it's just one client which has come, and the server is waiting for rest of the clients to vote for yes or no. So this logic will handle that part. So if data is not sent, like if the client is not, that means if all the clients have voted for commit or abort, then input from all, that means we have got input from all the clients. If no, like waiting for inputs from other clients, that means we are still waiting for the input from rest of the clients. And in case if we get input from all the clients, then it will be a global commit. This logic will simply tell all the rest clients that we have a global commit. So in this part we don't care about the abort part, as we have used this, like we have taken care of the abort part first and then the commit. It's like to make one thing true, all the things should be true, and to make a thing false, even a single false will work. So that's why we have first to use this abort logic and then this commit logic. These are just server closing, socket close. Now we will discuss this client file. Okay, so client file implements runnable. So again we will have to use this run method, which will be having the main core logic. So these are just socket declaration, input, output stream, buffer, reader declarations, and initializing the objects. Now we have initialized, like these are the default initialization, and now we have initialized all these objects with the socket has been mapped to the server, then input stream, output stream, input reader. Now this is for checking. Yeah, so when we get connection to the client and output stream, input stream all are working, not null means we have something in it, that means the reference. Then we will create a new client and we will start the thread. So as soon as the new client is created, it will get connected to the server, and server will display the message of welcome to two-phase commit protocol. We will see when we will run the program. So now print line, so this is input line and read line, like we are printing this thing, and this thing will print that first method, which the first message which is sent from the server. So what first message the server is sending? Yeah, enter your name. So this will print in the client terminal, like it will ask the client to enter his name. Okay, after that, yeah, here is the code logic. Okay, so string respond line dot int lead line commit committing. Fine. Yeah, sorry, let's come again here. So after it asks for entering the name, this thing will, like, we are still in the while, so till it's not closed, it will ask the first message, it will ask for the name, then it will show that it's in two-phase commit protocol. You will receive a request, vote request now, then it will send, the server will send to client to vote for commit or abort. So all these messages will be shown us by this line, like output stream will print from input line that we are getting, and like read line is the method which will be reading from all the messages which are sent by this server. Fine. So after this, we after this, like when we will be done here, the client will have been voted for commit or abort. So now in this run method, the client will wait whether to commit or not. Like the client has voted for commit or abort. Now it's waiting for the rest of the clients to commit or vote, and then the server will decide. So this is the part where server decides and sends the accordingly sends the message whether to commit or roll back to the client. So if input stream, like it's reading from the server, like whether server has sent global abort or global commit, like global commit and global abort, and accordingly it will take the action of committing or rollbacking. Anything else? Yeah, the link for the code will be in the description, and we don't need any jar or anything for this code. And I think this code is quite complicated for few, so you can just Google the simple version of the code. But the only thing which is important in this assignment is just this, like we will create multiple clients, and even if a single client says no, that means the whole transaction will be rolled back. So now let's run this program and see what output we get. So first we will run the server. Yeah, server is running. First client, we will name client 1. Yeah, so as soon as we entered so as soon as we entered the our name, it's showing. So this line is printing that it's an two-phase commit protocol. You will receive a request for vote and vote for commit or abort and all these things. Then we will start another client. Yeah, so it's second client 2. It will get the same method, and yeah, so this is client 2. This is the server. Now server has total number of 1, then 2, and in the client 1 it will get a new client, a new user. It's the name, and enter the application. Client 3. So now it will also get the same method, same message, and now this time this client 2 will get a new user. Client 3 has entered the application, and client 1 will get 2 messages for client 2 and client 3. And on the server side, this is the server. we will see that there are 3 clients now connected. So now let's vote for commit or abort. So this is client 1, so now we can vote for commit. We have voted, client 1 has voted for commit, client 2 also for commit, client 1 is voted for commit, waiting input from the other clients. Now the third client. So now we will see that, so we have committed for, like 2 clients have committed, and if the third client aborts, it's a global abort, and all rest of the clients will also, like this is server, so the client 3 aborted, since abort, we all will not wait for inputs from other clients, aborted. And the rest client, like this is client 1, though it's committed for, though it's voted for commit, it will also get a global abort, and same the client 2. So this is how two-phase commit protocol works. That's it.